In this problem, it tells you the graph of the polynomial function is shown. Why did they show us the graph on this picture and the next question they don't? This one is actually telling you what the zeros are. Use the zeros to write the polynomial in factored form. Well, the zeros are the pink dots. X equals -2. You're putting in -2 here. This one's going to be x equals -1, x equals 2, and x equals 3. Raise your hand if you got that. Now, we have to clean this one up. Class, what's the opposite of -2? What does that one become? X plus 1. So, I'm going to multiply the first two binomials. Class, x times x. X times 1. 2 times x. And 2 times 1? 2. So we first multiply from the outside of the box to get the inside of the box. And then from inside the box, you're going to combine like terms. Put your fingers on the two like terms. Class, if I add those together, what do you get?
3x.
Yeah. So let's write our answer on the top of our green here. X squared plus 3x plus 2. Now I'm going to multiply the purples. X minus 2, x minus 3. Class, x times x. -3 times x. -2 times x. And -2 times -3. Positive 6. Now, on the inside of the box, we're going to combine like terms, and I'm going to write my answer for the green. Class, which ones are like terms?
The -2x.
So what do you get? Your answer? X squared. Remember, you're adding, so -2 minus 3 gives you -5x plus 6. So essentially, the orange, your answer is x squared plus 3x plus 2. And then we're multiplying that by the purple, your answer from over here. And that's how I'm getting the green. Let's multiply now these two together inside our big green box. Class, how many x's are here?
2.
And how many here?
2.
That's why x squared times x squared is 4x's. Do we write 4x? What do we write?
X to the 4th.
X to the 4th. How many x's over here?
2.
Here? So how many x's do you have? We write x cubed. X squared times x is x cubed, and you have that leading coefficient. Class, 2 times x squared. X squared times -5x. (3x) times -5x. (5x) times 2. X squared times 6. 6x squared. 6 times 3x. And 6 times 2. 12. Now, as the boxes get larger, you can do color coding if it helps you. You can also put check marks to let you know that you've actually touched the graph. Class, are there any like terms with x to the 4th? So, x to the fourth. I'm going to write my answer down here. Ran out of space. X to the fourth. Check. Put your finger on the next two that are like terms. Hopefully you recognize the pattern. Negative 5 plus 3. Negative 2. X to the 6 or x to the third? When you are adding or subtracting, you don't actually, you look at just the term and its exponent just to help you figure out if they're like terms. Well, these two are like terms, so you just look at the number in front. 3 and a negative 5 gives you negative 2. This is the answer that we're writing is for the second bullet point, so I ran out of space, so I'm just writing it there. These three are like terms. Six plus 2 and 8 minus 15. Good. Negative 7x squared. Did I run out of colors? I have a darker purple. These two. What do you get?
8x.
And the last one? Let's highlight that in red. Might come up later. You'll notice my answer is in descending order. Descending order is by the exponents. 4, 3, 2, 1. This is x to the 0 power. And you'll also notice that when you're not missing any terms, it comes out really nice like this. They're already kind of in like terms diagonally. Read this question for us here. Lizeth?
Describe the end behavior of the polynomial function.
It was next door.
You got me tripping.
Now, the end behavior, we got lucky on this graph because it actually has a graph. In the next question, you won't have a graph, and it actually asks you to sketch the graph at the very end. So let's pretend there is no graph. How would you know what the end behavior is? Put your finger somewhere on the polynomial. There are two ways to know how to write that. The first one is your leading coefficient. Class, is this positive or negative? Positive. Oh, we forgot to answer this question, which will help us. Determine the degree of the polynomial. Put your finger on the degree. Now, this is your second clue. Our degree is 4. Is this an even or odd degree? What's the easiest one? X squared. What does x squared look like? Starts up, ends what? Up. So our end behavior has a sentence. Class, what does that sentence start with? As. As what? Yep. Positive infinity. What is our graph going to look like? It goes where? It goes up. So up is positive infinity on the y values. Pay attention. As x what? So now we're going towards the left. Again, let's just say you don't have this graph. Go back to your easiest one. What happens? It's going where? Up, which is positive infinity. So that's the describing of the end behavior. Hopefully the leading coefficient and the degree of the polynomial helps you figure out even if you don't have the graph. Brendan, go ahead and read the next bullet point. Determine.
Determine the y-intercept of the polynomial function.
Put your finger on the y-intercept. On this polynomial, it's the last one. There's a couple of places where the 12 is. Let's highlight it on our graph. Class, what's the order pair there?
0, 12.
Your x value is 0. Your y value is 12. If you put in x equals 0 here, 0 to the 4th power, what is it? 0. 0 times anything? So these are all zeros. So your answer is just the number at the very end. If it doesn't have an x, it's called the constant. This is your y-intercept. So our answer is 12. And the last question, Natalie R., read for us. Identify.
Identify the domain and range of the polynomial function.
Remember, the word domain refers to which axis? And the x values, I want you to move in which direction? Left to right. So I put my pen down vertically. Remember, the x-axis only. Don't think the y-axis. The first thing I touch is this arrow. Where is the arrow coming? What direction is it coming from? From the left side of the x values. If the left side of the x values are negative infinity, the common mistake for the student is to think the arrow is pointing up. Well, up is the direction of the y values. I'm just talking about the x values, so left to right. So negative infinity as I go towards the right. That means there's more values over here, so that would be positive infinity. Remember, for the domain, if you have arrow to arrow, it's always going to be negative infinity to positive infinity. Let's do the range. Class, the range refers to what? The y-axis. You're going to start from bottom to top. Pay attention. Are there values down here? Is the graph down here?
No.
So you can't say negative infinity. But the graph starts here. On the y-axis, that's what? Negative 4. Okay, this might be a little bit new to you. Here, I'm going to use a bracket. And as the student last period asked, why is it a bracket? Essentially, anywhere you have a graph, it is actually a closed circle. So really, a graph is a bunch of closed circle solutions. And here, we're saying include this solution. Including means a bracket. Parentheses means do not include it, or it will be an open circle. So I go from the bottom, I start at negative 4, and I end where? Positive infinity, which is a parentheses. So given the graph, let's summarize. I can get a bunch of clues. I can get the zeros. I can put it into factored form. I can multiply all of these out and now get standard form. Standard form tells me the y-intercept. It tells me where the arrows are based on the leading coefficient and the degree of the polynomial. And then you can also figure out domain and range.